We've already talked about the unit circle, so we're going to kind of gloss over some stuff as we talk more in depth about what I need you to be able to do with the unit circle. Remember, the unit circle is the circle whose radius is 1. Since it's a circle that's centered at the origin, and we've already talked about circles, its equation is x squared plus y squared equals 1. I want to show that point P, which is at radical 3 over 3, radical 6 over 3, is on the unit circle. Well, when you have the equation of a circle, any point that actually lies on the curvature of the circle gets plugged in for x and y. So if I plug in square root of 3 over 3 for x and square root of 6 over 3 for y, I square them and I add them, it better equal 1. So what do you get when you square the square root of 3 over 3? Well, you get 3 over 9, which is 1/3, right? And then when you square the square root of 6 over 3, you get 6 over 9. I'm going to leave it instead of reducing it because they have a common denominator. And 3 over 9 plus 6 over 9 is 9 over 9, which is 1. Just like with terminal rays, on the unit circle, our initial or starting ray is always going to be the ray that lies along the positive x-axis. Any other ray is going to represent the terminal ray. And this point where the graph hits, or where the terminal ray hits the unit circle, is called the terminal point. Terminal ray, terminal point. And then this would be my angle. Because remember, we go counterclockwise if we're going to use positive angles. And if we go clockwise, it would be a negative angle. So if I went this way, it would be negative theta. Now, the other thing that's really important to remember is these 4 particular points, although we are going to end up memorizing all the terminal points for all the special angles on the unit circle. These 4 points are very, very important. This one hits the unit circle at 1, 0. This one hits at 0, 1. Over here, it's at negative 1, 0. And over here, it's at 0, 1. Remember, when we start in our initial position, it's 0 degrees or 0 radians. And then if I go in the positive direction, 90 degrees is pi over 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi over 2 radians. And then you're back at 360 degrees, which is 2 pi radians. Let's find the terminal point on the unit circle determined by each real number t. All right, let's start here with t is equal to 3 pi. Well, how do you get to 3 pi? Well, you start here at 0, right? And then pi over 2, 1 pi, 3 pi over 2, 2 pi. Well, if this is 2 pi and I need to be 3 pi, I need to go another pi. And where am I at? I'm over here. Well, if I'm over here, it hits the unit circle at negative 1, 0. Negative pi. Well, if you start here at 0, to get to negative pi, you have to go clockwise. So you would be at negative pi over 2, and then here would be negative pi. And again, it hits at negative 1, 0. Remember, these are called coterminal angles if their terminal rays end at the same exact location. For the last one, negative pi over 2. You start at 0, and it's negative, so you go clockwise, and here would be negative pi over 2. It hits the unit circle at 0, negative 1. The point P, which is at square root of 3 over 2 comma y, is on the unit circle, but it's in quadrant 4. Find its y coordinate. Well, I can go and use this formula for a circle. The only thing I don't know is y. Well, it's just an equation that I'll solve for y. So first I plug in x, and then I square it. And then I subtract 3/4, and 1 minus 3/4 is 1/4. And then I square root 1/4, and square rooting fractions is easy. You just take the square root of the top, the square root of the bottom. Thing is that the answer is positive or negative 1/2. Which one is it? Is it positive 1/2 or negative 1/2? Well, remember that these are the quadrants. And we want to be in quadrant 4. In quadrant 4, are the y values positive or negative? Well, they're negative, so y must be negative 1/2. We've been talking about the special angles as well in the unit circle. And we've talked about finding the ordered pairs where each of these special angles hits the unit circle. Now, obviously, 0 and pi over 2 are easy because we've already done those. But the square root of 6, which was 30 degrees, remember we said, well, you've got a 30, 60, 90 triangle. And the ordered pair is going to be cosine, comma, sine of the angle that's closest to the origin. Well, in a 30, 60, 90 triangle, the side opposite 30 is 1. The side opposite 60 is the square root of 3, and the hypotenuse is 2. And I know we talked about the unit circle as circle of radius 1. Don't worry about that in terms of finding sine and cosine. So the cosine of 30 degrees, or pi over 6, is going to be square root of 3 over 2. And the sine is going to be 1/2, because cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. For pi over 4, or 45 degrees, that's a 45, 45, 90 triangle. Its sides are 1, 1, square root of 2. So the cosine of 45 degrees is 1 over the square root of 2, and the sine is 1 over the square root of 2. And for pi over 3, or 60 degrees, the innermost angle is 60, and this one up here is 30. So this is 1, this is the square root of 3, and this is 2. So the cosine of 60 is going to be 1/2, and the sine is going to be the square root of 3 over 2. And if you can just know those three special angles, the other angles in the unit circle are just going to be the opposites of those if they have the same reference angle. Let's find the terminal point determined by each given real number t. So let's start here with t being negative pi over 4. Well, where's negative pi over 4 going to be? Well, it's going to be down here, right? Well, negative pi over 4 is going to have that same ordered pair that pi over 4 has, except for you're in quadrant 4. When you're in quadrant 4, x is positive, but y is negative. So that would be the ordered pair of, or that would be the terminal point. Now let's think about 3 pi over 4. Well, remember I said there's a pattern to how this works. This is 0. This is 1 pi over 4, 2 pi over 4. So 3 pi over 4 would be here. Again, it's going to have the same ordered pair as pi over 4, except it's in quadrant 2. Well, in quadrant 2, x's are negative and y's are positive. So negative 1 over radical 2, positive 1 over radical 2 would be your terminal point. Now let's think about negative 5 pi over 6. All right, same thing. Let's do it this way. So you start here at 0. If we're going in the negative direction, remember we are going clockwise. So negative pi over 6 would be here. And then negative 2 pi over 6. Negative 3 pi over 6. Negative 4 pi over 6. Negative 5 pi over 6 would be here in quadrant 3. It's going to have the same ordered pair as pi over 6. The ordered pair for pi over 6 was square root of 3 over 2, comma 1/2. Except since it's in quadrant 3, we know that both x and y are negative. So the answer must be negative square root of 3 over 2, comma negative 1/2. I mentioned this phrase just a moment ago, something called a reference angle, or our textbook calls it a reference number. I'm used to calling it a reference angle. The reference number or angle is going to be the angle measure, whether it be in radians or degrees, between the terminal ray and the x-axis. And just to make this easy, I'm going to show you an example in degrees because it's easier to work that way. So, here's the unit circle. Let's say that I have an angle over in the first quadrant. I'll say it is 25 degrees. Well, I need to know how many degrees it is between it and the x-axis, which is right here. Well, the reference angle is 25 degrees. Well, now I'm going to move my angle to quadrant 2. Let's say I have, I don't know, let's see, what's a number between 180 and 90. Let's say 135. The reference angle, or reference number, is going to be the number of degrees between that terminal ray and the x-axis. Well, the terminal ray is at 135. The x-axis on this side is 180. So 180 minus 35 is 45 degrees. That would be the reference angle. Now let me move my terminal ray to the third quadrant. Let's see, I'll pick this angle here. Let's see, something less than 270. Let's pick 260. Why not? All right, 260 is an angle that would be in the third quadrant. The reference angle, or reference number, is the number of degrees or radians between it and the x-axis. Well, again, over here the x-axis is at 180 degrees. So the difference between 180 and 260 is 80 degrees. That would be the reference angle. All right, let's move this party to the fourth quadrant. Here's my unit circle. I'm going to change colors. How about I pick 300 degrees? The reference angle is going to be the number of degrees between the terminal ray and the x-axis. Well, this time the x-axis is going to be 360. Well, the difference between 360 and 300 is 60 degrees, and that would be the reference angle. I want you to notice that in all four of these cases, the reference angle is always an acute angle. The reference angle will always be a number between 0 and 90. All right, let's find some reference numbers, but now we're going to do this in a little bit more difficult fashion. We're going to work with angles that are in radians, because as you saw, working in degrees was pretty easy. Working in radians is going to take a little bit more work, but for an honors class, it should still be pretty easy. All right, let's start with 5 pi over 6. Well, finding its reference angle when it's in radians is super easy, because the denominator is always going to tell you what the reference angle is. It's going to be pi over 6. If you don't understand why, let's go back to our unit circle and figure out where 5 pi over 6 is. Okay, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Here's 5 pi over 6. Well, if that's 5 pi over 6 and this is pi, all you have to do is subtract them. This is going to be 6 pi over 6 minus 5 pi over 6, and you find that it's pi over 6, and that's the reference angle. Again, radians are actually pretty easy. Well, the ones that are in terms of pi are. So, how about if the angle is 7 pi over 4? Its reference angle is going to be pi over 4. Okay, so let's go do this the long way. Here's my unit circle. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over here. Here's 7 pi over 4. We want to know what this angle is, and this is 2 pi. Well, what's 2 pi minus 7 pi over 4? That's 8 pi over 4 minus 7 pi over 4, which is 1 pi over 4. All right. C. Negative 2 pi over 3. Well, guess what? The reference angle is pi over 3. It doesn't matter if the original angle I give you is positive or negative. It kind of works the same way. Now, why is it? Okay, so here's my picture. And let's see. Here's negative pi over 3. Remember, that's 60 degrees. So if you go another 60 degrees, here would be negative 2 pi over 3. Well, I need to find this distance here, and this is negative pi, isn't it? I'm going to subtract those. So what's negative pi minus negative 2 pi over 3? Well, that's negative 3 pi over 3 plus pi over 3, which is negative pi over 3. But we don't say that the reference angle is negative pi over 3. We always give it the positive angle. So even if you get a negative answer, that's okay. Just make it positive. No weird math involved. How about D, though? That one's kind of wacky, isn't it? I gave this radians in numerical value rather than in pi form. Well, one of the things we learned from the Smarty project was that 1 pi was somewhere over here, or I'm sorry, 1 radian was somewhere over here. Well, if you want to know what it is in radians, just remember, what's pi? It's 3.14, so 3.14 is over here. Pi over 2 is like 1.57. 3 pi over 2 is, I don't know what it is, it's 4.61, something like that. And then 2 pi would be 2 times 3.14, which would be 6.28. Well, if you know that 2 pi is 6.28, where must 5.8 lie? Well, somewhere in here, right? How do you find the reference angle? 6.28 minus 5.8. About 0.48 would be the reference angle. You can use the reference angle to help you find the terminal points, otherwise known as cosine, comma, sine, of other angles in the unit circle. So let's look at the angle of 5 pi over 6. I know its reference angle is pi over 6, which means that it is some variation of this ordered pair. I just don't know if one of them is positive or negative or what. Well, if you know what quadrant 5 pi over 6 is in, see, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, here's 5 pi over 6. It's in quadrant 2. If it's in quadrant 2, then x must be negative, and that's the answer. I know that for B, 7 pi over 4, the reference is pi over 4. Therefore, it has to be some variation of 1 over radical 2, 1 over radical 2. The question is, should either of those be negative? Well, it depends on what quadrant 7 pi over 4 is in. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Here's 7 pi over 4 in quadrant 4. In quadrant 4, y is negative. And then negative 2 pi over 3. Its reference angle is pi over 3, which means that the answer has to be 1/2 square root of 3 over 2. Except it kind of depends on what quadrant it's in order to know what should be positive and what should be negative. So remember, it's negative angle. So we're going to start with negative pi over 3 and negative 2 pi over 3. Well, it's in quadrant 3, which means they're both negative. The last thing I want to do is I want to talk about angles that are larger than just one circle around. We've already talked about finding coterminal angles. The easiest way to find the terminal points, to find your value of cosine theta, comma, sine theta, is if you're dealing with angles that are between 0 and 360. Or, in radians, that's 0 and 2 pi. Well, 29 over 6 is bigger than 2, because 2 pi is the same as 12 pi over 6. So if that's bigger, then the easiest way to approach this problem is to start by subtracting a circle and see if I can get myself between 0 and 2 pi. Well, 29 pi over 6 minus 2 pi is going to be, let's see, 17 pi over 6. Uh-oh, that's still bigger than a circle because I just said that a circle is going to be 12 pi over 6. So I'm just going to do it again. So 17 pi over 6 minus 12 pi over 6 is 5 pi over 6. So it turns out that 29 pi over 6 and 5 pi over 6 are coterminal angles. That means that they're going to have the same answer. So I can actually just find the answer to 5 pi over 6, and that'll be my answer for 29 pi over 6. All right, next. Since it's over 6, I already knew the reference angle was pi over 6, so the answer has to be some variation of the square root of 3 over 2, comma 1/2. But it depends on what quadrant 5 pi over 6 is in. Well, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is here. It's in quadrant 2. In quadrant 2, x is negative, so that must be the answer. How do I approach the problem? First of all, I got myself to an angle measurement that was between 0 and 2 pi. I did that by subtracting 2 pi. I had to do it twice, though. That's okay. I found out that 29 pi over 6 was in the exact same location as 5 pi over 6, because they're coterminal angles, which means that all I have to do is find the answer for 5 pi over 6. The nice thing about radians is the denominator is going to tell you the reference angle. So I knew the reference angle had to be pi over 6. That means that the answer had to be square root of 3 over 2, 1/2, but something is probably negative. So the last thing I did was determine what quadrant 5 pi over 6 was in. When I figured out it was in quadrant 2, I determined that x had to be negative. And that's how I found my answer.